Hi, good morning, afternoon, evening, wherever you are. My name is Bailey Hayes, and I'm here with Luke Wagner.
Hello.
Uh, and so we're going to have a pretty chill chat talking through kind of a little bit of the history of WebAssembly and the evolution of the standards going from, as early as 2015 to now. And right now, there's a lot of exciting stuff. So hopefully that's what we end on and end with a lot of excitement. I've been part of the WebAssembly community for a while, mostly as an end user in the 20 teens. But more recently, I've been helping work on some of the standards and am the one of the directors for the technical steering committee for the Bytecode Alliance. But here I have Luke. Luke is really one of the original creators of WebAssembly, and he has been there, since it was written. So I'm really excited to talk to him about it today. Luke, do you mind sharing a little bit more about yourself?
Sure. Yeah. Thanks for having me, and thanks for organizing this. I'm excited to be here. About myself. So, I guess I joined Mozilla as like first job out of college, and I was working on the JavaScript engine and performance. And then we had a games program where we're trying to say, can we make games run fast in web browsers? And so that started with saying like everyone's porting their games to the web using Emscripten to compile C++ to JavaScript, which when I first heard about, I thought was kind of a crazy idea and like wouldn't work well. And I thought it'd be really slow, but then it was surprisingly fast. And then it started to work well enough that people started to be like, no, no, make it really fast. No, like do this real. And so we started to like look at it and be like, how do we make this really fast? And then so I started working on this Wasm project. And I was kind of like the implementer inside Firefox for Wasm.js, which Bailey, you know all about, but it's this precursor to WebAssembly, and it helped kind of scope like what problem are we even trying to solve here? Because one does not simply just add bytecode to the web. So we worked on this Wasm.js, and then it was kind of great but kind of goofy. And so then all the browsers were like, could we not do better? And that was our kind of are tiptoeing into let's actually make a new standard here in WebAssembly. So I guess that's my little
Yeah,
background into this.
let's time box that. Asm.js, I remember seeing. I feel like it was December 2011, but really it like caught fire. I saw a blog post, I think, by Alon Zakai at the time, creator of Inscripten,
Hmm.
and I believe in 2012 was when I first got early POC working, which like blew my mind, taking C++ and using Inscripten to compile it to Asm.js, which if you're not familiar, I would say think of it as JavaScript light. There are certain things you're allowed to do in JavaScript, and if you fulfill those contracts and you have a use pragma Asm.js, the browsers like Firefox are able to optimize that code in a way that gets it a lot closer to native speeds than your regular old JavaScript, which I would say sometimes can be 60 times slower. Is that accurate, Luke?
Yeah, no, that's a great description. It's Asm.js is a goofy thing. It's hard to describe because you're like, well, it is JavaScript, but it's like a subset of JavaScript, but we're not changing the spec at all, but we're optimizing it way differently. And so it performs like significantly differently. And so it was kind of an adorable hack that
It,
worked.
I call it the greatest hack of all time. So let's not downplay it. It was amazing, and I think probably what people saw was running the Unreal Game Engine with lighting effects and everything, shaders, all that kind of stuff in the browser, but also Doom because everybody has to be ask the question, but can it run Doom? And the answer was yes, of course. Okay, well, you know what? I like drawing things out, especially when we're talking about times as we flow through things. So, if it's cool with you, I'm going to start drawing things over here in Excalidraw, and I'm going to
Yeah,
start
totally.
with this initial era. So, I believe it was 2012 to would you say 2015 would be kind of like the Asm.js era, or would you extend that even further?
Yeah, I forget how early Alone started Emscripten. It was surprisingly early, like maybe 2011 or 2000. I wonder if it's nine, but at least 11. I think he was like doing things and getting things working, and so it grew just of his own single person project, just getting things working for a couple years before people started like taking it pretty seriously and like starting to like using it for like actual like company company ports to the web because Flash was starting to go away, and so that was getting or that was on the horizon, so people started looking to Emscripten for that. So yeah, 2011ish to, and then we started at Asm.js properly at in right after my daughter was born, which is like middle of 2012. And so it was like this like furious 5-month, 6-month implementation thing, and then we demoed it at GDC Game Developer Conference in March 2013, I think. And that started the ASM.js. That was like the release of it, and then we kind of kept pushing that rock up that hill as far as we could get it up. We did like the caching, storing machine code in the browser cache, index or something. Parallel compilation. Uh, one other thing that I'm forgetting, and so lots of optimizations for the next 2 years between like year and a half between like 2013 and like the middle of 2014 when we started to say, could we not do a little better? Because we added this growable memory, and it was just the grossest thing ever. ASM.js was already pretty weird, but supporting growable memories involved this massive pattern match. You had to write this one grow memory function that had to look just this one way. And we were like, this can't be the way that we evolve this platform forward. And so that's when we started to and how would in 64-bit even work? And how would SIMD even work? And how would GC even work? And so that's when we started to middle or late 2014 is when we started to talk to the other browsers about maybe starting a new standard.
And so what was that like? Did they tell you you guys are crazy, or had they seen the success of ASM.js and wanted to be a part of it?
Yeah, so at the point in time when we started talking to everyone, we already had Microsoft. They implemented ASM.js in Chakra we specially licensed that part of the code with a license that was compatible with Chakra because Chakra is about to open source it. So you can see some of our Mozilla code in Chakra code base. So they had ASM.js. So that kind of added a lot of weight to the ASM.js code and made the other two browsers be like, hey, what are you doing? And so then when we were talking to the VA people who kind of really hated it because it seemed kind of gross, or at least a lot of them did. Mr. Aleph wrote this blog post like why I don't like ASM.js. And so they had kind of taken a stance against it, but we were like, hey, and they're like, how could this be the for all time solution to this problem? We're like, what if it was just a transitional solution to a new, better bytecode that could be polyfilled in terms of this? Then they're like, and that's, I think, Ben Titzer in particular, one of the long-term WebAssembly standards starters, was like, oh, are you serious about that? You want to talk about that more? Really? And then so we started this, it was basically me and him convincing our management that the other one was on board. And so we started to kind of use each other to say, yeah, let's try to start this thing. And then we started talking to all the other browsers and getting everyone on board and saying, well, everyone else is doing it. And if you don't do it, we'll just polyfill you. And I built this polyfill that just took ASM.js and it compressed it to a binary format that went over the wire. And then client side, it took that binary format, expanded it back into ASM.js in a big array buffer, and then script sourced it as a blob. And that worked. And it was fast enough. They were like, that polyfill totally works. And we showed it to everyone. We're like, this is what you'll get if you don't, get on this standards train. And it worked.
Okay. How about from the Apple side? Were you
Yeah.
talking to anybody there?
Yeah, pretty early. Ben Titzer and I went out to have drinks with Philip Pislow on the JSC team, who really also didn't like ASM.js too much. But it was like, oh, standard and polyfill, so we don't want to be the only one not doing it. So he kind of all that adds up to So they were on board from the very beginning, and the very first kind of big meeting, all the people from all the four browsers. Major browsers were there, and so everyone, you didn't trigger that why wasn't I consulted sort of reflex that often kills standards when it's only just developed by one person and one browser and then dumped into the open.
How often do you feel like all four browsers get together and agree?
Not that often.
So it's a big deal, I feel like,
Not at the beginning of a standard. I think a lot of takes time. Like certain things it took like WebGL took a while before all the browsers, and that's actually I think common for a lot of these standards is there's an early one, maybe a second one, and then it starts to slowly tip in the third and the fourth get on board. And I guess now we're down to 3.
Okay, so now we've got all four browsers, they're talking, everybody's kind of like, yeah, we've got to figure this out because otherwise we're going to be stuck with the greatest hack of all time, but still a hack. So what happened then? I saw the post, I think it was around the summer of 2015 when I started seeing folks talk about the WebAssembly design, but I assume a lot of folks were probably talking a little bit before that.
Yeah, so we had a big old GDoc that I just found. It's actually hidden in the very earliest commits of the public WebAssembly design repo is this link to this GDoc that we were all working on. It's like roughly what are we talking about? And it was just agreeing on the high order points of it's basically scoped to ASM.js, but with the warts cut off, a few things missing spots filled in, and a binary format for that. And we're going to optimize for load time aggressively. and a bunch of other sort of things. Like it's gonna be like a module, and initially the goal was it's gonna be just like an ES module. The only way to load it is as a module with an import and a script type equal module, that sort of thing. But then the ES modules weren't, well, there was a lot of challenges to that, so we had to punt on that. But anyways, yeah, this was like where we discussed in this design document all like kind of the high level shape of it. And then once we're all comfortable with that basic design, then we made a public community group in the W3C, which is like this really like lightweight way to like start working on a thing without having to have like a whole bunch of like legal stuff immediately come at you. And so we started it, and then started a repo, and then started throwing up markdown design docs and arguing a lot.
Yeah. So I think one of the more interesting things that I observed in real time, watching all the design discussions happen, there was a lot to talk about. ASM.js was sort of like state-based, I guess would be one way to describe that. And then with WebAssembly, made a pretty big change from how a lot of these tools worked to sort of this more, I guess, would you describe it as like more of a AST kind of model? Do you remember any of that? I might be imagining it
Oh,
all.
yeah. Well, yeah, there was a whole sequence of iterations we did. We started with thinking of WebAssembly as kind of an AST, and that kind of felt really nice because we're like, yeah, we know what that is. And then we're like, yeah, but it's like a pre-order serialized AST. And then ultimately some of the Microsoft people were like, that's a bad idea. You should really do a post order because it makes sense for all these reasons. So we did a big breaking change to a post order, and then we kind of dropped the thing of it's an AST at all because now, and then it just became just a proper stack machine. And some people initially were really turned off by the concept of stack machine because of their bad experiences with early Java, when it was a stack machine, but it also had like really weak validation semantics. So you had to do this like algorithm that was worst case like Quartic to like let it converge on what the types of things were. But then later Java fixed that with type stack maps or something. But people were burned by that, so they're like, no stack machines. But eventually we're like, okay, stack machines,
All
because it's a
right.
nice enough formalism.
So basically, at that point, we've got sort of a virtual machine that is really, stack machine, stack-based architecture. Were there other big design points that kind of came out as part of this sort of iterative standardization?
Yeah, a lot of time was spent talking about control flow and how to even do control flow, because we started off, somehow I forget exactly what. Well, I know what it was. We wanted to reuse all of our compiler backends that we already had built for our JITs, and so like this was part of the coolness. Is like we're not building a whole new compiler. We're just using a thing that's already in the engine. It's already super optimized for like 5 to 10 years here. And so it's really part of how this is just a very minor addition to the web platform. It's not like a whole separate plugin system, which is what we really were trying to get out of and away from. This is going to reuse the backend of compiler, and the backend of a JS compiler gets to assume you have structured control flow and a reducible control flow because JavaScript has that property. And so some of the algorithms fundamentally depend on that. And so not wanting to just break that assumption, having to do major deep surgery to these compiler backends, that kind of pushed us initially very strongly into the let's require reducible control flow, which is this concept. If you can't have certain wacky control flow patterns, you can kind of describe things in terms of like what you have in Wasm now, like blocks and loops with single entry properties. And so, but one does not simply just do that in assembly language. There wasn't a thing we could point to and say, yeah, that's exactly what we want. So we kind of had to debate that a lot. And, it's a lot of time was spent on that.
Okay, that worked out. I was able to make a little iteration for that.
You're awesome here. This is live diagramming. This is amazing.
No, well, it helps because I was on the sidelines. I was watching. I was cheering. I could tell this was really something, right? There were a lot of things that I wanted the W3 standards to work on for W3C standards to work on, like mouse events. I think was one thing that was driving me crazy, and font rendering. I was trying to get like pixel perfect font rendering in the
Ooh,
canvas and
yeah,
being able to
that's
measure
super hard.
fonts. Like there were a ton of standards I was watching, but this was like the one. This one I thought we're talking about creating the fourth language of the web. Did people bandy that around at the time? Did was that like gravity on you, feeling like hey, we haven't had another language added to the web in 20 years.
Yeah, well, we definitely felt like it's almost like there's a road and there's bodies scattered all around this road, and we're about to walk through it. Kind of like in the Neverending Story when the main character walks through the sphinxes that kill you if you have fear or something. It felt like that. So we're like, don't do anything that messes up. Because at any time, we're assuming like the lawyers show up or the suits show up and just shut us down by overwhelming us. We're like, just go, just like radically throw away things if you can get away with it. And what's so nice is we're running in a browser. So many hard things we could punt on, be like, oh, do that in JS. If it's not absolutely essential, if it's not like, if alone can't it can do without it, like or as long as mscripting can produce something that mostly targets WASM with a little bit of glue code, we're good. So there was a feeling of like this often doesn't work. So far, we have these magical preconditions that we're all on board. So let's just go as fast as we can before something stops us. And because it
So
did feel like magic, a little magical.
can you give me some, let's go back to like timelines, right? Like, okay, so I get in 2015, it's like, okay, we're designing this, we can tell that we're onto a thing. We are walking through the land of sphinxes. And we have a lot of things that we have to figure out. And you landed on the stack machine. I'm not sure if that was 2015, that could have been 2016. But can you walk me through like 2015, 2016, 2017-ish?
Yeah. Let's see. So I guess to put the bookend at the other end of it, by 2017 March, we shipped in Firefox and Chrome in the same month. And then 3 months before that, we had what we called like the developer preview release, I believe, which is where we had like a single binary format that wasn't, we didn't call 1.0. We're like, we're going to allow ourselves to make one more breaking change, namely going to 1.0, but there's a little version field. And we're like, at least we're going to change the version field from OX whatever to 1. So we're definitely going to break you one more time. So this is a preview period. We're going to collect one last round of feedback, make the last little binary tweaky changes, and then it's 1.0. And we did that like 3 months before. And that was like, again, between Firefox and Chrome, being able to like run the same, Unity app, I think it was like Angry Bots in both browsers. So that was like 2016, like near the ends. And so, yeah, we actually made surprisingly fast progress. And then sometimes when we get to the more recent standards, I'm like, why are we going so much slower? But a thing I forgot was that you can think of all the research, basically starting with Alone in 2011, as all leading up to this is like the preparatory work of how do we even compile to the web? How do we even run in a browser? What's the scope? What's inbounds and what can we like punt on? Like, and ASM.js, all that was a gradual scoping thing. So by the time we actually got to like 2015, we had scoped it. We knew like roughly how to do it. We had existing implementations. It was like our second iteration of things. So like this last 2 years was just kind of almost like a polish by comparison to the overall process. So that's yeah. Also figuring out how linear memory worked or memory worked at all, because people are like, why don't we just mmap? That was like a big discussion of like, all right, look, one does not simply add mmap to the web, right? Mmap does like 20 things. Some of them are right out. Some of them we absolutely need to emulate that functionality, and some are in the middle. So and people wanted to have a plan. It's like, okay, we're not doing it now, but what would it look like in the future? So there's a lot of discussion of how memory works. And in particular, also, I guess a high level discussion was like, how deterministic are we? And like, there's a whole spectrum. And WASM ended up at almost entirely deterministic, except for a few things that just simply we couldn't possibly be deterministic on these things, at least within our current our assumptions then. But when we started, we were like, oh, maybe we should give ourselves flexibility, fast. That's fun. And so a lot of the discussion was like, yeah, actually, you can have determinism while being still quite fast. And so how memory works played into that. Linear memory is contiguous because of determinism. If you kind of are like fully like mmap, where stuff pages can just show up randomly in different places in the address space, that's very non-deterministic, and you get bugs. The type of bugs that like when I run it 2 different times, it crashes one time and doesn't because the addresses are different because you got different mmap locations. Like these are the sorts of things we wanted to try to avoid by design because they're much worse at web scale.
I think we should dig in a little bit more on linear memory, because I feel like that is one of the coolest properties for WebAssembly that leans itself to like part of our security model, and why that is so powerful. And I'm sure we haven't really said the word security yet, so maybe
Oh,
you
yeah.
could talk through that part in the design.
Yeah, I guess that was where we wanted to like, there were various things that would trigger various people in our browsers. And one was around anything around security. And we just wanted to have this simple line. It's no less secure than ASM.js. It's the exact same model. And this is a thing, we just kind of inherited it for free. Alone just found this pattern that worked. He's like, put all memory in the array buffer, use the JavaScript native stack for the actual compiled control flow stack, which was kind of a little radical, not putting the stack in memory. It's like, can that even work? Because a lot of previous kind of low-level sandboxing techniques put the control flow stack in memory, and then you have a very big source of non-determinism there, because the addresses of the control flow stack are very non-deterministic, and you can mutate them, and you have to say what happens when you do that. So all sorts of wacky stuff happens when the control flow stack is in your a memory that you can load and store from. So we had this model where they were separate, which gave us like a huge boost of determinism, and also safety against those sort of return address programming or stack smashing, all those sorts of attacks where you corrupt your control flow stack. So we just got that for free just by what Alone kind of just found with mscripton. So yeah, we basically wanted to say up front, no less secure than what WASM is doing now, which is obviously fine because it's just JavaScript. And then we just kind of like stayed with it. That kind of like, it was like a lucky coincidence of, yeah, that
That's
worked.
wild. I didn't know that. So this is pretty cool. I like, from all the documents that are produced, that are kind of like externally public and for people to consume, especially like the specification document, for example, it hits on all the different parts of why it's no less secure. But I had no idea that it was just a benefit of having started with basically sandbox JavaScript and the way that it was done from before. So that I love it. I love it. I just learned something that I had no idea. So
For a
that's so
while,
cool.
our internal tagline for ASM.js, like it was like ASM.js : boy, we got lucky, because several things just worked out. Like, first of all, the bitwise operators, they work in JavaScript. They have just really nice properties that are like, if they had been slightly differently, like we might not have been able to do asm.py, right? Like just just because the language happened to work differently. It just certain properties of JavaScript just kind of were really conducive to ASM.jsifying it. And then ASM.js kind of set us up in a very clear, like, do WASM like that.
So at any point in this part of the timeline, did anybody talk about WASM being run outside of a browser?
Oh yeah, so that from day one, I was even looking at this, like from the very first public design documents, we had a non-web embedding section, and our basic idea was, don't like, definitely this thing is designed to run in the web, but don't add a single dependency on JavaScript or web APIs in WASM. Make it kind of pure in that it has to import things. It doesn't just get to assume a JS global object. It doesn't get to assume any sort of JS primitives. Doesn't assume web APIs. And we could kind of see that this would maybe be useful. We weren't sure it would be, but because JavaScript was already doing its big leap from the browser into Node.js, and that had already kind of happened, and that was already clearly a thing that might happen to WebAssembly. And in addition, the native client folks who had joined forces with WebAssembly, they were already, I think, kind of thinking in that direction already with their sandboxing approach. And so they kind of already had even more concrete use cases in mind. So we kind of made this goal up front that we should reserve the possibility that it runs outside a browser, but we just, that just mainly meant don't build in certain sorts of dependencies, but otherwise we kind of didn't know whether it would happen or not. We were like, maybe this will just be a browser only funny thing. Who knows what'll happen.
Yeah, for folks listening, and for me myself, I came to WebAssembly from the web, and I realized that that's definitely original use case, number one use case. Let's get that amazing for running in the web, and you had all the right people in the room, all the major browser vendors interested in implementing and participating in the design. But I just want to say, oh boy, did we get lucky that we had you, Luke. Because you made sure this was done in a certain way within the web. And that means that now we have this really special thing that I haven't seen anywhere else. Sometimes WebAssembly gets compared to the JVM. And I imagine you were probably getting is it like Java applets starting, even here, right? Like all the way
Yeah.
probably back to the beginning.
Yeah, I had to give that presentation to internal people of how is this not applets?
Do you want to give that, because I still get that question even now.
Yeah, I mean, there's a lot of broad similarities, and in fact, we learned a lot from the JVM, and a lot of people who worked on WebAssembly formerly did their research, PhDs sort of research on JVM. So we definitely built on that, and so it's not entirely different, and so it's not a bad metaphor to draw, but some kind of high level differences, like particularly with an applet. An applet is not just code; it's got this whole black square of pixels that it can arbitrarily render to, and there's a lot of value in the web in using the DOM. There's so much accessibility, so much customization, so much native. All these things come from mostly we're doing with the DOM. So if you have a new code delivery technology that's coupled to, and this is how its UI looks in a browser, that would have killed it. So it's that decoupling of saying when I load Wasm, it doesn't come with a little applet box, right? It's using the same APIs to do its I/O as JavaScript does. It doesn't kind of set the web aside in that respect, and that's quite different than any plugin technology. So the lack of any sort of big pixel array is important difference between applets. And that's not necessarily Java, that's more like applet specific, how we're different. And the other big one that's more Java specific is Java bakes in a certain kind of object-oriented language model, not exactly Java, because obviously there's like Kotlin, Scala, and so many other languages, but they're all kind of in a family that have a certain object-oriented foundation to them. And WebAssembly tries to be 1 degree more language neutral and be like, it's just a bunch of bytes. We're not, like baked into the JVM, you have classes, you have virtual dispatch, a particular way that works, field, public, private, like inheritance, all these things are baked into the fundamental substrate. And so all these languages kind of have to use those as primitives. And so WebAssembly is like more language neutral in that respect. And then the last major dimension is JVM comes with a whole giant class libraries, like huge amounts of functionality, which is fantastic, batteries included, but it means it's not this ultra minimal thing that I can just like drop in all these really exciting futuristic scenarios that I'm sure we're going to get to at the end. And it's that lack of class. It's so funny. Like the way we're different is we just didn't do a lot of stuff. We were extremely lazy and extremely minimalist because of the aforementioned bodies along the road, and we just had no to so many things. We're like, well, it's in the web already. Just call it JavaScript.
I mean, there's a lot to be said about keeping it simple, right? It's really going back to that really simple model of ASM.js, the greatest hack of all time, means that you got something that had already a great security model that you just had to not break it.
Yeah,
was basically the goal, right? Okay, so I started that with kind of a leading question of, hey, have we thought about running it outside the web? When would you say on the timeline of things that people started kind of discussing that possibility?
So the first time I even heard anyone seriously talking about it was actually when my current boss, Tyler, showed up to a CG meeting and started just chatting with us. And we had been developing this open source Rust-based new compiler backend called CraneLift, and he wanted to build something on CraneLift. And he's like, "Is this gonna go away, or is this for reals? Because I want to maybe build a whole thing on this." Which he built Lucid, which is this Wasm engine that's since been merged and fused with Wasm Time to use in Fastly to run in a CDN. And so when he showed up and he's like, "Yeah, I'm actually doing this," I was like, we were like, "Tell us more." Like, what? Like why would you like because we had thought that most of the things that motivated WebAssembly, like the security model, were like, oh, that's a browser specific thing, and because we just didn't know anything that much about what was going on server side. So he was just talking through the motivation and all the alternatives and why this was the optimal WebAssembly was the optimal thing for him. Really low latency startup, really tiny sandboxes, short of it. And so that was like kind of a big eye-opening event. And the second thing was blockchain people started showing up really early. And I remember I think Parity was one of the first, and then a bunch of them grouped together and they gave us like a joint presentation. They're like, "Let me tell you about blockchains." And we're like, "What?" And somebody's like, "Have you heard about Merkle trees?" I'm like, "No." That's all about them. So that was the other one that showed up very early. And I don't know when that would be. That would maybe be like 2018, end of 2017. Well, maybe I don't know. I forget exactly when I first heard about Tyler and what Fastly was doing.
We'll add an ish and we'll put it kind of here. All right. So 2017, whoa, WebAssembly shipped to Firefox. All the other vendors, quickly kind of followed suit. I know for sure that here-ish, I actually shipped to production for the first time with WebAssembly if the browser supported it and the versions matched. So glad you had different versions in there, by the way, because there weren't changes, right? And I needed to ship a new binary, but that was it blew me away. But also the performance between, I would say, here and here and here and here, like from 2017 to 2019, it just continued to get amazing. Do you want to talk through some of the stuff that happened after 2017 shipping?
Yeah, that's right. That is mainly what we did between 2017 to 2019 is polish and performance. And there's just a whole bunch of optimizations that like I'd been wanting to do since ASM.js started because we had this AOT compilation model, which is not usually what you want. You want to have kind of done all your compilation before you start running, and that gives you that like buttery smooth frame rate when you start up, which was kind of unique. That's like part of the motivation for doing this ASM.js in the beginning was before ASM.js, you would have this giant code base and you start running it, and now the jitting's happening while you're rendering it, and so you have this really stuttery, janky experience as you're loading up this video game, and it just feels like really like low quality. And we're like, ugh. So we wanted to do AO compilation, but now you had this big load time up front. So that was like kill that load time was like the whole goal. So things that we did in Wasm, like we could do streaming decoding of this stuff. So that's what I personally wrote during this time period, and so that means reaching out and plugging into the network stack in the right areas and like adding streaming to the JS engine and stuff. So streaming compilation, we already had the parallel kind of function by function compilation, but optimizing that pipeline. So as like memory efficient and all this stuff was a lot of optimization to that compilation pipeline. We added a baseline JIT made by just the most amazing piece of engineering work by Lars Hansen. In that it just had such good performance, and it was so fast. It was like this perfect sweet spot of like how much work to do compiling versus how good is the speed of the code. It was like less than 2x slower, or often around 2x slower than our most optimized code, and you could produce it like 10 to 15 times faster at basically line rate. So as the bytes are coming in, we're streaming them, we're putting them this parallel compilation pipeline, we're baseline compiling them, and we're assembling it so that when the last byte arrives over the wire, we already have code ready to run. So basically we got to this point where like there is basically no real like assuming various reasonable machine things, you can run this thing as soon as it's over the wire at less than 2x slower than optimal speed. And then in the background we kick off this full optimizing thing that just swaps in transparently. And then we added the logic to stick that machine code in the cache, in the HP cache, transparently. So the next time you visit that thing and you get a cache hit, we pull the optimized machine code out of the HP cache. So they added a whole separate caching thing to the network cache for us, but then to use for other, now it's used for other things in the browser too, but it was to add an alternate representation of a resource. You could have like the bytes that came over the wire and then your process version of them. And that fundamental functionality in the network cache is what allows us to stick the machine code in it. For a while, we were storing in IndexedDB, which seemed like a great idea, but then it was like a terrible idea as I can learn more about caching. So we had to add it and then do all this work to rip it out. This caching's tricky.
Caching, one of the hardest things in computer science, right? Yeah, totally. For me, one thing you may not have mentioned there was that it also was doing this compilation off of the main thread.
That's right. Yeah.
So when I did the ASM.js stuff way back here, it was there was this like stutter moment that was noticeable in browsers, and so when we were talking about dejanking, there's that runtime part, but there's also that initial part that really just like caused the browser to sort of seize up.
Yeah, for like 20 seconds on big use workloads, it was terrible.
Yeah, I think I got to scare some of you guys with our use case one time at CPPCon. We were showing alone, and it was like, so we have a module that's like easily 30-ish megabytes. And what we found to make that work in IE, what we did is we put it in a try-catch finally block, and it was the finally block that actually forced the browser to just move into an interpreted mode to avoid that initial seizing. Anyways, hacks on hacks on hacks, but doing
that's funny.
Streaming compilation off of the main thread and all the different various parts of that control flow there are so important. And at least as me as an end user, like I was describing, going through this, you could feel it. The entire time it's just getting better and better. And around, I would say 2018-ish, which is about where we are on our little timeline here, it felt like everybody should be doing this. If you have a super large application and you need it to be portable, please consider doing it this way.
Yeah. And I forgot the other, in addition to all that load time stuff, we spent a fair amount of work basically optimizing JIT trampolines between JS and Wasm, calling in and calling out, because those used to be these slow paths. And so if you cross the boundary a whole bunch, it would just kill you. You had all this performance once you got in, but people it's funny, it was sad. They would do this, they would be like, all right, I'm going to port this cute little piece of code, run it in Wasm, then call it in a loop and benchmark, and all of a sudden it's 10x slower because all the time is in the trampoline hopping into the Wasm. So that was a fair amount of complicated JIT work done by Benjamin Bouvier.
So I love that you keep calling out all the different people, because I think that's like one of the coolest things about WebAssembly is that you've got all these different browser vendors, the major players in the market, some of the greatest engineers in the world, all in different places and working together as like a team to make this. And it's one of those beautiful cases in open source and open standards that worked. There's a lot of places where some people will say too many cooks in the kitchen kind of problem for this stuff, and this was just like an example of it working really, really well.
Yeah, yeah, I think you're right. It definitely doesn't it doesn't always go so well. Too many cooks in the kitchen is a frequent failure mode.
Yeah. Okay, so it's 2018. Let's go ahead and get into 2019. 2019, officially fourth language of the web, right?
Yeah, yeah, that's when, the spec was doneish. Once it's shipping a browser, you're like, all right, we're not changing it. It is in the wild. You can't put that genie back in the bottle. But then, we went through all the process to get this becoming a formal W3C rec, which is their highest level of standardization that they have for web specs. So that's when it made rec.
Okay. So when did sort of WASI, this like when we started talking about nano processes, what time did that start?
Well, the idea started percolating even actually before we started caring about. Well, when outside the browser was still more hypothetical, we were just like, I want a compilation target that's just WASM. It's not WASM in JS in some sort of strange, like, how do we rationalize this? How do we produce a unit of code that in a browser will feel just like an ES module? That was the high level goal. Is like using WASM from a browser should feel like I just import a module. How do we actually make that experience? And then like from a compiler tool chain, like it's hard enough to get do a new ISA that's a little different, which is WASM, but also now we have two languages. We have this glue code. Like how do we even rationalize this so that tool chains can feel mature and we can like upstream this in all these places instead of being like this special snowflake? So even at that level, we were like, we need some sort of like standardized thing that's pure WASM that we can target that like kind of takes the role of like the operating system syscalls, right? Like that's usually what happens. You're like, well, I'm on Linux, so I'm just gonna make these syscalls and pull in the libc that gets to make those syscalls, and I use the libc. But we're like, what's that for WASM? And that's just these questions get very abstract very quickly. So it's so unconstrained of what do you want to do? What are we even trying to do? It was a very unconstrained time, but we knew we needed something, and then we started seeing the outside the browser use cases showing up, and so that kind of helped make things more concrete. Like, yeah, we kind of need to do this. And so and we need to do it before something kind of awful becomes the standard accidentally. And so and this was mostly led by Dan Goman, just being like, well, what exists and what's the philosophies that we want here? And capability based security, of course, old idea since like the 60s in operating systems. That came up. We want that. We don't know exactly what that means. It's a fuzzy concept, and you have to go read a whole bunch and definitely read some Mark Miller dissertation stuff. But internalizing some of that capability-based security of what that, and then finding something we could build on, which was Cloud ABI. And so Dan did a ton of work to distill from those things WASI. And then we kind of put that out there as a preview. We knew we'd need to change it. We needed to do so many things, but we need to get something out there just to like, almost like put a flag in the ground and be like, this is a thing we're going to be working on. And then as soon as we did that, we're like, all right, it didn't seem like it was going to be that giant of a project, but it just immediately opens up all these questions. So, but I guess just answering that question, yeah, 2019 is when we were like, yeah, we need to do a thing. Let's scope it. Let's call it WASI. Let's announce it. Let's start a subgroup to discuss it. And then in that same year, announcing WASI, also we're like, and how do we write these WASI interfaces in a language agnostic way? And so that also birthed interface types, which is what we called it then. We called a lot of things over time, as you probably know, including at one point in time snowman bindings, the Unicode character. But yeah, we also started that also in 2019. So 2019 is when we kind of started officially embarking on like saying like, what would it mean to make a compile target for WebAssembly that's not assuming the browser?
Yeah. So I started getting really excited about this. I don't know. Gosh, I feel like 2019, it was a sweet, beautiful year because we didn't have COVID yet. We didn't know it happening, right? But I saw this. We also saw the founding, I believe, of the Bytecode Alliance. Is that right?
Right. Yeah, that's the third big thing of 2019. I forgot. Yeah.
Do
Because
you-
we were
uh,
realizing we can't do this alone. It was the high level point. This is too big to go it alone.
I agree. And can you say a little bit more about the Bytecode Alliance? Who are some of the founding members?
Oh yeah, so certainly, Fastly, who we had been working with through Crane Lift and just showed up to lots of meetings and hosted some meetings. And then what? Red Hat had some folks. Intel, were those the three? Yeah, I think initially those were the three, and then by the time it was officially formed, then Microsoft also was in the initial founding group, if I'm remembering correctly.
Yeah, and now we have a bunch more.
Yeah. Do you know what the count is by now? It's
In the 20s, I think.
Mhm. Yeah.
I just looked at like the logo map, so I should have this. Especially, I feel like now in my new role, I should have this like on the tip of my tongue, but I don't have it. I'm sure it's easily findable though. I think now you look at it and you say, "Wow, okay, so this is like all the major players in the industry is working on this, and we're pretty excited." And a lot of the Bytecode Alliance sort of the promise is being able to run in many different environments, not just for the web, but also continuing to support the web ecosystem, and trying to figure this thing out with WASI and running, creating different runtimes that are able to run outside of the web that can work really well for Fastly, like you were talking about Lucid getting merged into Wasm time. So I imagine this was a lot of 2019, and we had no idea what was coming.
Oh yeah.
Let's
In so many ways.
let's in so many ways. So let's talk about 2020.
Well,
What
there's some
what would you like to
COVID.
say here?
Yeah, that there was all these things we were thinking about doing at the beginning of 2020 that took a lot of our time. We were like, something big is going to happen outside of the browser, and Mozilla seems like it should participate in it so it can help shape it, even though Mozilla is a browser company. This seems like a contradiction. Is this a contradiction? Let's discuss this internally. So we had to spend a lot of time talking internally about, is there, also Mozilla would probably like some more revenue sources. So is there a business opportunity for Mozilla here? And so that we spent a lot of time thinking, and it's hard, right, when something's so new to even think what is how would you even, there's so much we didn't know. So we spun our wheels a lot trying to think about how it might show up in some sort of product. So that's stuff we were doing at the beginning, at the end of 2019, and the beginning of 2020. And then COVID happened. And we're like, yikes, what's going on? And then, there were some layoffs at Mozilla in 2 rounds. And then the second one, I think, got a few people on the WASM team, and we're like, but we really like those people. We want to keep the band together. And so we talked around, is like, anyone want to hire all of us? And then fortunately, Fastly said, yeah. So we kind of, like, I think 8 of us, 8 or 9, I forget, just all kind of, the Rangers who weren't fired left. And then we moved over to Fastly and basically kept working on this thing, except now instead of having to convince everyone a browser vendor should work on WASM outside the browser, there was now a very clear case of why we're at a company who specifically wants WebAssembly off the browser and standards around it to develop. So that kind of just removed a whole sorts of tension and time spent. So that was actually ultimately a very nice move, although very uncomfortable during the middle of it.
Yeah, I imagine changing roles within COVID is pretty tough. I jumped around. I went from SaaS to single store around this time too. So I was feeling that. I went from some Go microservice stuff, some WebAssembly in the browser stuff, to getting WebAssembly working in a database. So that was a pretty cool transition. And so
Very cool.
there's some stuff that's happening around this time, right? We got some different WASI proposals coming through. And I realize Dan, is spearheading a lot of that work. But do you mind giving us a quick overview of what we're kind of seeing change in the WASI space?
And are you specifically asking about the 2020 time frame here, or just even now? Because I'm not super clear in my memory of exactly between now and then what happened when.
Yeah. Okay. Maybe we should just say, all right, we're gonna call a COVID mulligan and go to 2022. Let's talk anything that happened somewhere between COVID and 2022 slash we're never really gonna be gone of COVID, but to when we started having WASM Day and everybody was really excited about talking about WebAssembly outside of the web. We should talk about some of the standards that were happening around that time.
Yeah. So yes, and this is, I guess, as we're working on a lot of these WASI standards, and we have this abstract goal of capability-based security, there's this immediate question, we invited Mark Miller to come talk to the WASI group, and like this basic question, everyone's like asking all these like, well, it should work like this or this or this or this. He's like, what is your unit of isolation? Which is like, you can't even have a discussion about capabilities if we're all in the same unit of isolation, because inside of unit of isolation, just assume everyone has everything. To have a meaningful capability model, you need multiple units of isolation. What is yours? Is it a process? Is it a container? Is it a microservice? Is it a what? Is it a vat? Is it a container? I said that one already. Is it a compartment? These are all terms that have that existed. So that raised a lot of fundamental questions like, so at the moment, WASI didn't have anything about processes. Everything logically ran inside a single process. There was no way to spawn a process, much less talk to two processes. The process story was simply fuzzy. And we knew we hated fork. But other than that, it was fuzzy. Fork has all sorts of problems. But so we're like, well, what is our unit of isolation? If we don't define one, we don't have multiple, we're all in the same one, we don't have any capability-based security. We're all I-32, all of our I-32s are indexing the same global thing. So that kind of started us down the path that eventually led to the idea that we need a component model, or this is our unit of isolation, the definition of this component model. So you could say, like, asking this question in a WASI context, and then saying that, okay, if we're not sharing linear memory, how in the world do we like communicate between two of these things? Is it all messages or sockets or streams? So how do they talk? And we're like, well, we have this interface types things going, which is saying, let's have value types and let's say how we copy them between two different memories, or between WASM memory and the browser and vice versa. So we kind of like repurposed interface types and said, hey, that is going in a direction. We've talked about some types, definitely need high level types. And if we're going to do capabilities, we need like handles. It can't just be like pure plain old data, because if I force you to use plain old data, you're going to have to stringify all your capabilities, and now you're not capability safe again. So we also need handles in this thing, one way or another, like in operating system file descriptor. That's something like that. So we kind of repurposed interface types and grew it into what is now called the component model proposal. But it's basically solving that fundamental question of, if you want capability-based security, what is your unit of isolation? And so now we can say that is a component. It is defined by its own standard that is a lower level below WASI. It just defines this thing. You can use defined components that have nothing to do with WASI, that import just whatever random interface you make, or just work on the browser using purely browser APIs. But with the component model as a foundation, we can now start to define WASI interfaces and say, how do they give handles that are only owned by one component and not all components at the same time?
Yeah, and I would say starting around this time, we also started re-envisioning WASI itself. I think one of the clear things that we can see through this timeline is that we're constantly finding different ways to think about the problem and scope it to the right level. And with WASI, we were initially like, okay, let's just like make libc. It was kind of
right.
The early version of that. And now we're starting to see a ton of new higher level APIs like that, the Deus Labs team pitched, WASI messaging, WASI key value. So several things that, you might not think of for libc, but they make a lot of sense in terms of portability.
At the beginning of the journey, it was like, okay, what we're trying to do here is define one fixed small set of APIs, and then all the other stuff goes through that. And that's kind of the traditional POSIX thing. It's like, okay, can you force it to look like a file or a socket? Great. And then all the APIs are like these high level things that you express with bindings generation on either side, but everything's funneling through sockets and file systems, like kind of in a POSIX mentality. And so as we started working through all the capability-based questions and how do we not lose the capabilitiness that we seem to have, how do we not lose it? We kept being like, well, we can't funnel everything through these typeless interfaces. We need to have, as you were saying, lots, a garden of high-level interface types. And if we're going to have lots of them, like, the nice thing about having one small fixed untyped set of APIs is you can say, well, that's it. We're going to build all the tools to just that one fixed API. We build it in and it's done. And now we've punted the problem to everyone else can work on top of this. But we're like, okay, if we don't want to funnel everything through this low level set of things, we want to have high level APIs. We have to have bindings generation because everyone's going to be doing this. We're going to have lots of these things. So we have to generate a bindings, which we wanted to do anyways for interface types, but now we had like a second reason. And so all this kind of converged to saying, yeah, we don't want to force everything to go through file system sockets. We want to make it easy to just throw out lots of different interfaces that are specific to the particular problem, and then have those interfaces. And you could be like, well, a ton of interfaces, won't that just like lead to giant proliferation problems. And so the other half of that thing is, which we also know we wanted from like kind of the beginning, is we want to be able to virtualize these interfaces. We want to be able to implement an interface also in WASM. We don't want to have interfaces that can only be implemented by the host, which is like, sounds like a nice thing. You're like, yeah, duh, yeah, of course you want that. But it's like a really hard design constraint that like is like constantly like, well, why are we doing it this way? Because of virtualization. And so we have the property currently with the component model that when you import or export a thing, you can't tell whether the other side is another component or the host. And what this means is, of course, you can implement the host using components, which is cool for reducing trusted computing base, or you can take a component that can't run on your host and you just slap on some components, and now it is you compose it with some other components, and now it is a thing that can run on your host. So it gives you all these wonderful properties, but it's a serious design constraint that we did not appreciate fully when we started, and has very much shaped the path we've taken to where we are now.
Yeah, and so I've drawn another diagram from some time ago. Let's jump over there, and that can talk through some of the different things that I've seen happen over time. Right, we've had the 2019 sort of the libc POSIX feel, but then we started reimagining things with like WASI clocks and WASI file system, WASI random, WASI IO, right? And then we saw WASI and WASI crypto. So a lot of those blockchain folks that we talked about before, they came in with a really nice proposal there. I included proxy WASM, although it's not necessarily like a WASI specific proposal, I believe, but I think
a lot of great work went into it, and we're sort of wanting to morph that into a WASI HP proposal that's just a slight kind of resyntaxing of the basic ideas that are in proxy WASM.
Yeah, I guess part of the reason why I put these together is that I felt that we started seeing purpose-built APIs, right? We went from this kind of like one big blob, which was sort of WASI common, and then we kind of started breaking them up into smaller pieces, even though it's still kind of like one big thing that people are aiming for. And that was kind of WASI Preview 1, right? I put a big old circle around it. But then, right, we're starting to talk about what we call as a group as WASI Cloud, but really they're each an independent interface that we're proposing. We and then WASI HTTP comes onto the scene, right, as you were saying, so to kind of fill the need that proxy WASM wanted. I just pitched this one. It's not even really a thing, but just to give an idea, the International Collation library ICU for C is probably one that people have heard of. It just seems like one that everybody's going to want or everybody's going to need, and every system everywhere has it.
So, and it's like large binary size. Getting to factor that out, yes, that's a great idea.
But this one plus like 100 others. I could just sit here and roll of ones that I would like to exist that don't yet exist. But all of this kind of comes into the component model. So I think we should talk a little bit about what Preview 2 is, and we're going to hear more from Dan and kind of like how he sees that roadmap going during the W3C subgroup of WebAssembly, which is the WASI subgroup. I believe Thursday, which is now tomorrow time. But yeah, do you mind giving a little high level of that?
Also, great diagram. This is like a really cool visualization, and like you're using like multiple dimensions and nesting and stuff like that. This is cool. Sorry.
Thank you.
What did you ask again?
I've distracted you with it though. So we've talked a little bit about what Preview 1 is, but we haven't talked at all about what Preview 2 is.
Yeah, I think in my mind, Preview 2 is all right. We've kind of rebased WASI on the component model, and now we're doing it all through it properly with shared nothing interfaces that are virtualizable, and will very soon have handles and resources properly, like kind of we needed from the beginning, and now like we can properly have them because we have our unit of isolation. And so we're going to re-update all of our existing proposals, capture that functionality now in WITS, so the file systems, the sockets, the clocks, and all those things, and then we're going to add a bunch of new stuff that wouldn't have made sense in a libc only world. But now that we have all these high level types, like you were saying, we can just have just a bunch of these things. So it's HTTP makes so much sense, and a lot of these other ones too. And it's not clear exactly which interfaces will go into Preview 2, but that we'll pick some collection and say, okay, together we're going to have these, the redoing of these old ones in terms of WIT, or the existing ones, and then these new ones, and then that collection of interfaces, as well as the component all below it, all of that, we're going to make this stable release that people can like actually generate WASM modules, components that can run portably on multiple hosts and actually show this interoperability, which is what we've been working for this whole time. So yeah,
I love that.
bit of it.
Yeah. And so to be clear, when we're talking about this, we're talking about WebAssembly, but really in the scope of doing standardized interfaces and specifications within the W3C. So that includes WASI, which is a working group within the W3C, and also the component model, which is its own proposal for the WebAssembly side of things.
That's right.
But at the same time, a lot of us also work within the Bytecode Alliance. And I kind of relate this to we're implementing all the standards that are coming through from the W3C. So it's not part of making standards, but it's about making an ecosystem and a software foundation that you can build on top of and consume those standards.
Yeah, I think it's definitely the right framing is Bytecode Alliance. It's all about implementations of proposed standards with high quality.
Exactly. And Wasm Time is one of those. We've got Wasm Tools, Wasm Bindgen. A lot of the things we talk about is binding to different languages, and now even a little bit about like how do we take these components that have been produced and distribute and consume them. That's something else that we've been talking about within the Bytecode Alliance. I want to go back to my timeline. Okay, so we've started doing lots of things. We've come up with different standards. Those have kind of evolved, especially in the WASI side of things. Yeah, hey, actually, I just had a question if we could share this, and totally. Brooks, if you don't mind sharing just a view-only version, I would love it. I could also try to make this not so crazy, because obviously we're just live whiteboarding here, and I didn't plan any of this really ahead of time. So yeah, I mean, I would love it if people want to jump around, because I imagine I've been kind of scrolling around for myself, and that's probably really kind of chaotic to watch. So if that really, confused you, I'm sorry. We'll get better at it over time too, I think. But
I think
okay, awesome. Back to the now. What are we doing right now, Luke?
Ooh, we're doing a lot of things right now. I think the high order bit is getting to this preview 2 kind of stability point where we're like, all right, here is some interfaces you can use and some components you can produce, and they'll work interoperably and they won't break on you immediately until we have a preview 3. And then even then we won't break them. We'll just add some more stuff. In fact, we're going to try not to break you until we make a final go to 1.0, and then we'll have tools that can migrate those previous components to whatever 1.0 is. So getting to this first point of like real stability of saying, yeah, things have stopped. The edge is not so bleeding anymore. So there's a lot of areas to flesh out, a lot of work fleshing out WIT. We're still doing a lot of great things building up WIT, which is this IDL that you use to describe these component interfaces and generate all your bindings from. So lots of things around WITs. Adding these handles and resource types is right now sort of thing we're right about to start doing, is actually implementing them. They've been kind of designed and spec'd, and a whole bunch of thought and formal developments on the type theory of these things has happened. So now it's actually time to implement them. And then using those handles, then we'll be able to update our current WASI interfaces to avoid doing the cheating using integer indices, and instead use proper handles so that we actually have the real capability-based security. That is a big thing we're doing now, but there's also like 20 other things we're doing that so many people are working on. So I feel bad not enumerating every single one, but I won't be able to.
Yeah, we're kind of close on time. We have world files is one example that we didn't talk about. We've got use us. Just defining your own IDL is a lot of work, and so there's a lot of different aspects that are happening there. I would say that when you think about how this flows through the system, I'm gonna jump back to one of my other diagrams, which was something like here. When we implement things, doesn't have a hyphen here. I'm losing my mind. We have the runtime, the WebAssembly runtime, but that is kind of like the final place, the final destination for a WASM module. Really, to get there, you start with things like having bindings that you generate that the WASM module, we call them guest bindings, but the WASM module wants to consume things. Say it wants to consume some of these different APIs, or maybe it implements some of those, and we need to know that. That's the guest side of things, but also the host needs to be able to speak this too. So we've got guest and host bindings happening. whenever we come up with a change that happens over here, we have to go and implement them here at each one of these layers throughout the stack. Um, and I think it's a pretty cool thing that we have so many different people involved. I recently went and looked through like everybody that's contributing across the Bytecode Alliance, and we easily have about 20 to 30 active contributors on any given day
Nice.
that are working at each one of these layers. And so,
Hmm.
it's I love highlighting Luke, and he is the spearhead behind the component model. But there are so many wonderful people that are working all across that we're building this really cool ecosystem. So I
And
think in the last few minutes, Luke, I'm going to ask you to just tell me why I should be so excited about the component model.
oh gosh, I'm bad at this sort of. Um, I think it's just going to solve a whole lot of problems that everyone who wants to do WASM outside the browser runs into. It seems like, oh yeah, I'm using WASM. It's standard. I should be able to like run my WASM everywhere. That roughly feels like it should happen, and it's not quite possible today. The component model will actually start to make this possible, this actual interoperability, getting some choice in where I run this code, how I run it, different performance, different placement, different all these things. I think that's really exciting, getting a lot of different languages. Okay, so there's one is that's that one angle, and the other one is if you're a programming language person, you now have an answer to a whole morass of hard questions of how do I target WASM and bind to whatever. Like this is just like a huge hard open question, and now you can have a very clear target. You're like, there's wits, I generate bindings to the wits. That's it. That's I don't have to ask 1,000 more questions about. Well, tell me all the different hosts and how does the browser work and what even like a lot of languages don't even know how a browser works on the inside. Now there's this one thing you target, build the components, bind to wit, add a wit bind generator, and you're good. Your language now can like participate in this ecosystem, and you've done the right amount of work, which is I've taken care of my language specific stuff, and I don't have to think about so many different hard problems that we've been working on.
Yeah, and I mean, on that note, can you list some of the languages that you've seen start getting active in this space now?
Oh yeah, so there are so many languages working on WebAssembly and WASI. That's a really large list, but specifically with binding generators, so like very much targeting the component model explicitly. We have C, JS, Rust, Go via TinyGo, Java via TVM, uh, Kotlin with CoWASM project, Python, at least on the host side, but maybe also on the guest side. I forget. And then I think I'm probably forgetting a few more. Do you have any that are in
I'm
your head?
dropping in TypeScript. I've seen some work there happening. It's very
Nice.
exciting.
Hmm.
Um, Gosh, I feel like there's so many more. What about Ruby? Have they started working in the WIT stuff? I know they're in the WASI side of the house.
That's right. Yeah, that's what I have seen. Actually, I've talked to somebody who worked on that, and they're like, as soon as things settle down a little bit more, I will take a look at this. So hopefully that
Yeah.
comes before too long.
So, I mean, I think these are the people that are coming in, or kind of the languages that are on the bleeding edge, right? We're changing a lot of
Hmm.
things. We're trying to figure stuff out. Um, but the fact that they're already there and contributing and giving us feedback so that we have this type feedback loop is just so amazing. But also kind of signals that I expect so many more languages to come online once we say, okay, this is a point of stability. Everybody
Hmm.
go. It's going to
Once the edge
be
is
kind of
not
an
so bleeding.
explosion. Exactly,
It is very
exactly.
painful. I have deep appreciation for every single person working on this right now because a lot of things are changing, but we're trying to get out of that stage, and things are only growing, not changing out from under you.
Yeah, but change means good.
Yeah.
Things are happening, right?
Hmm.
Things are getting added, so it's
That's right.
sometimes it's totally worth it, right?
Hmm.
Is there a question that you wish I had asked you that I did not?
We talked about so many all my favorite topics, so I nothing stands out. This has been a great little journey through history.
I love it. I mean, I kind of selfishly asked all of my favorite questions because I was there. I was watching a lot of this stuff, but I had no idea behind the scenes how a lot of these things happened. I was watching it from whatever's out there in public on GitHub, and so this was a real pleasure to watch. I will throw a link of this diagram in the YouTube chat, but we'll probably also make a blog post around this because I think it's really insightful. I think a lot of people think we come at this and we just have this perfect plan, and then we're just executing.
No, it's like the opposite.
And it's not
Stumbling
that.
backwards through a dark room.
Bodies and
Bodies
sphinxes
strewn
and
about, avoiding corpses, zombies.
yes, I think it's still we're still feels like we're heading in the right direction though. It's not that we're heading in many different directions. There's a vector and we're adjusting it, but still moving in the same general
I
direction.
feel like it's
So
an attenuating sine wave. It goes like this, and then it just.
I like that. I like that. Yeah. So if anybody else has any questions, please send them our way. We're on Zulip. That's the Bytecode Alliance Zulip. You can find me and Luke there. There's a general channel, but there's also specific channels to all the different projects that we work on. So yeah, it was a pleasure. Thank you so much, Luke, for joining.
Yeah, this was super fun. Thank you for this, and this is an impressive performance art. Just being able to live diagram this, you may have to do this for more subject topics. This is cool.
Next time I'm gonna have like a bunch of memes and pictures. Like there was a point where I wanted to throw in the XKCD. We had one standard that we wanted to change, or 14 competing standards, and now we have 15. That's kind of what it feels like. Next time I'm gonna be more ready for that. Just have XKCD at the ready, XKCD library.
Smart.
All right. Well, I think I'm gonna call it. So thank you very much, Luke. And see you online.
See you around.